we'll go for discussing the question from signals and system given in GATE 2010. Given that the transfer function of a discrete time LTI system, linear time invariant system, is given by h of z, capital H of z equals to 2 minus 3 by 4 z power minus 1 whole divided by 1 minus 3 by 4 z power minus 1 plus 1 by 8 z power minus 2. And here given some statements S1, S2, S3. So we need to find which are true here, which statements are true. Out of that we need to decide which answer is correct here. So out of the given options, here the option C is correct, that is both S1 and S3 are true. Nothing but the system is stable and causal for ROC mod z greater than 1 by 2, and the system is neither stable nor causal for the ROC between the z value between 1 by 4 and 1 by 2. Now we will see the solution for this. So coming to here, given that h of z equals to 2 minus 3 by 4 z power minus 1 divided by 1 minus 3 by 4 z power minus 1 plus 1 by 8 z power minus 2. Here by finding the roots here, by finding the roots of the denominator, 2 minus 3 by 4 z power minus 1 whole divided by finding the roots here, this becomes 1 minus z power minus 1 by 2, 1 minus z power minus 1 by 4. So here, in order to decide the system is stable or causal, we have the conditions that for stability we have the condition summation n equals to 0 to infinity mod h of n must be less than infinity, and also we can decide the stability using the ROC. So how we can decide the stability using ROC? So the system is stable if the ROC includes the unit circle in it. This is the condition for stability. If the ROC includes the unit circle, then always the system is stable. If the ROC does not include the unit circle, the system is unstable. The system is unstable if the ROC does not includes the unit circle in Z transforms. So this is the stability. Coming to the causality, to find whether the system is causal or not. So we know that h of n must be 0 for n less than 0. That is the condition for causality. So using this condition we can say whether the given system is causal or non-causal. So here given h of z, now we need to find the h of n from this, and ROCs, h of n and ROCs, we can decide whether the system is stable or causal. So finding the inverse z transform for this h of z, that is 2 minus 3 by 4 z power minus 1 divided by 1 minus z power minus 1 by 2 into 1 minus z power minus 1 by 4. Here it is applying the partial fractions, we can find the h of n, that is a by 1 minus z power minus 1 by 2 plus b by 1 minus z power minus 1 by 4. So by finding the a and b values, we will get a equals to 1 here, 1 divided by 1 minus z power minus 1 by 2. We already know that how to find the constants in the partial fractions, then we can easily find. So and b will get it as 1 only, so we will get it as 1 divided by 1 minus z power minus 1 by 4. So for the given ROCs, in the problem it is given that the ROCs, 3 ROCs are given, that is mod z greater than 1 by 2, mod z less than 1 by 4, and between 1 by 4 and 1 by 2. Now we will go for verifying the stability and the causality over these 3 ROCs. Then first we will go for taking the first ROC, mod z greater than 1 by 2, mod z greater than 1 by 2. So considering the ROC mod z greater than 1 by 2 here, then writing the h of n, we have the example that for x of n equals to a power n u of n, the z transform for this that is x of z equals to 1 by 1 minus a z power minus 1 for mod z greater than a, and for x of n equals to minus a power n u of minus n minus 1, the x of z is, this is also same, 1 by 1 minus a z power minus 1 only for mod z less than a. This is the ROCs we will get for these x of n's. Then here given it as mod z greater than 1 by 2, then mod z greater than 1 by 2 is nothing but that is greater than 1 by 4. Here the a value, here we can observe that the a value is 1 by 2, and here the a value is 1 by 4. Mod z greater than 1 by 2 is nothing but that is obviously becomes mod z greater than 1 by 4 itself, then we can write h of n, the inverse z transform for this 2 r 1 by 2 whole power n, u of n plus 1 by 4 whole power n u of n only. So here you can observe that we have the h of n value only for positive n values, we don't have h of n for negative n values. Then we can decide that the system is causal. Simply come into the stability concept. Here what is the ROC given? ROC given as mod z greater than 1 by 2. By drawing the ROC here, that is taking the circle with radius 1 by 2, the ROC is, this is the z plane, the ROC is greater than 1 by 2. Is nothing but you can say this includes the unit circle. The ROC includes the unit circle, then the system is stable. And you can also observe the condition. You can also find the condition mod summation n equals 0 to infinity mod h of n. This is also becomes finite only for the up obtained h of n, for the obtained h of n equals to 1 by 2 whole power n u of n minus plus 1 by 4 whole power n u of n. Then for this ROC mod z greater than 1 by 2, the system is causal and stable. Causal and stable. That is the S1 statement. S1. Coming to the statement S2. Statement S2. What the statement S2? In that the ROC is given as mod z less than 1 by 4. Mod z less than 1 by 4. So taking that ROC mod z less than, taking that ROC mod z less than 1 by 4. So mod z less than 1 by 4 is nothing but we can say mod z less than 1 by 2 itself. Mod z less than 1 by 2 itself. So from the obtained h of z, from the obtained h of z here, from the obtained h of z, this h of z, we can have 1 by 1 minus z power minus 1 by 2 plus 1 by 1 minus z power minus 1 by 4. Then we can observe that mod z less than 1 by 4, nothing but we have h of n. We have h of n equals to x of n equals to minus a power n u of minus n minus 1 for the same z transform, but because of the ROC this becomes minus a power n u of minus n minus 1. That's what we need to write here. So we have h of n, then we'll get h of n equals to minus 1 by 2 whole power n u of minus n minus 1 minus 1 by 4 whole power n u of minus n minus 1. Here you can observe that we have u of minus n minus 1 in both the terms, nothing but this is equals to 1 for n less than or equals to 1, nothing but h of n is having some values for n less than 1, n less than 1, n less than, here it is n less than minus 1, n less than minus 1. We have the values for n less than minus 1. Then we have the values for h of n for negative n values. For n is negative, then the system is non-causal. Then the system is non-causal. Coming to the stability concept. Coming to the stability of this statement S2. Stability of statement S2. So here given that mod z less than 1 by 4, taking the ROC mod z less than, taking the circle with radius 1 by 4, mod z less than 1 by 4. Mod z less than 1 by 4 is nothing but that includes only the circle with radius 1 by 4, but not includes the circle with radius 1. Circle with radius 1, nothing but unit circle. So the system is unstable. System is unstable. So we have the statement S2. We have the statement S2, that is, so in the statement S2 it is given as in the statement S2 it is given as system is stable but not causal. So that is wrong. That is wrong. We have unstable system and not a causal system. That's what we obtained here. So the statement S2 is wrong. So S2 is wrong here. S2 is wrong. Coming to the S3 statement. S3. So given it as 1 then we can write the h of n equals to mod z greater than 1 by 4. Greater than 1 by 4 means we can write it as 1 by 4 whole power n u of n. Mod z less than 1 by 2 means that is minus 1 by 2 whole power n u of minus n minus 1. So here it includes the, we have the h of n values for we have the h of n value first having some values for n less than or equals to minus 1, then the system is non-causal. Coming to the stability, taking the ROC on the jet plane, so taking the circle with radius of 1 by 4 and taking the another circle with radius of 1 by 2, taking the circle with radius of 1 by 2. Here we can observe that the ROC is greater than 1 by 4, and it is less than 1 by 2. It includes only greater than 1 by 4 and less than 1 by 2. It is not including the circle of with radius 1. It is not including the unit circle. Then the system is unstable. So was given the statement S3. The statement S3 is given as the system is neither stable nor causal. That is true. S3 is true here. So S3 is not true. So out of that we have S1 is true, S1 is true, S2 is not true, and S3 is true. Then the result is, then the final conclusion, we have both S1 and S3 are true out of the given options. That's what the solution for this.